Chapter 7 is about solving systems of equations. And there are several methods for solving systems. The first method we're going to look at is graphing. To get us started, let's look at our key terms. The following is an example of a system of equations, x minus y equals 2 and 2x plus y equals 1. A system is just working with equations more than one at a time. So there could be 2 or 3 or even more than that. We're going to focus on just 2 at a time. A solution of a system of 2 equations is an ordered pair that makes both equations true. The graph of an equation is a drawing that represents its solution set. And to solve a system of 2 linear equations, we can find the coordinates of any points of intersection on their graphs. In other words, the solution to a system is going to be where 2 lines intersect. Now let's look at the first example. We have a system, 3x minus y equals 1 and 4x minus 5y equals negative 17, and the directions say determine whether the given ordered pair is a solution of the system of equations. If it is a solution, then it will make both sentences true when I plug in 2 for x and 5 for y. So let's work with the top equation first. So I'm going to plug in 2 for x, and I'm going to plug in 5 for y, and we want to know, does that indeed equal 1? Well, 3 times 2 is 6, minus 5. 6 minus 5 is 1, and that equals 1. So it is a solution to the first one. In order to be a solution, it has to work in both. So now let's look at the other equation. 4x minus 5y equals negative 17. We're going to plug in 2 for x. We're going to plug in 5 for y. And we want to know, does it equal negative 17? So 4 times 2 is 8. 5 times 5 is 25. So does 8 minus 25 equal, or what does 8 minus 25 equal? It does equal negative 17, which makes this a solution. So yes, 2, 5 is the solution. If we were to graph these 2 lines, they would intersect at 2, 5. Now let's actually graph one and see if we can find the solution. In order to graph, you can graph any way that you like. You can graph by point plotting, you can graph by intercepts, or you can graph by slope-intercept. I tend to prefer slope-intercept form, so I'm going to get both of these equations in slope-intercept form. And that means I'm just going to solve both of them for y. In other words, I've got to get y by itself, and y equals then the x term. And it looks like I'm going to have to divide everything by negative 1 to get y by itself. That's going to leave me with y equals negative x over negative 1 to be positive x. 1 divided by negative 1 would be negative 1. So there's my first equation. And then my second equation, I'm going to go ahead and just get it in slope-intercept form right now. And then I'll graph both of them. So it looks like y equals negative x plus 5 on that one. So let's graph the top one first. My intercept is negative 1. So negative 1. And my slope is 1, or 1 over 1, so I'm going to go up 1 over 1. And then I'm going to draw my line. And now I'm going to graph my other line. My intercept is positive 5. And my intercept this time is negative 1, so I have to go down 1, right 1. And now I'm going to draw that line. Okay. Now I have to look for the intersection point. That point right there where they intersect is going to be my solution. So it looks like it is 3, 2. You could always plug in 3 for x and 2 for y into both equations to verify. So in my top equation, 3 minus 2 does equal 1, and in my bottom equation, 3 plus 2 does equal 5. So my solution is 3, 2. Let's look at this system. Again, I prefer to put them into slope-intercept form. The top one looks a little strange. X equals 2y. I'm going to rewrite it in slope-intercept form. So instead of x equals 2y, I'm going to write it as 2y equals x, and then I'm going to divide both sides by 2. And that's going to give me y equals, and instead of x over 2, that's the same thing as 1/2 x. My other equation, x minus 2y equals 2. Let's get this in slope-intercept form. The nice thing about putting it in slope-intercept form is you can also put it into your calculator to double check if you've got a graphing calculator. So we have y equals negative x over negative 2 would be a positive half x, and 2 over negative 2 would be a negative 1. So let's graph the top one. My intercept of y equals 1/2 x would be 0, and I would go up 1 over 2. And I'm going to graph that line. My other equation, my intercept is negative 1. My slope is also up 1 over 2. And when I graph this line, I get this. So it looks like I have parallel lines, which means if the solution to a system is where they intersect and my lines don't intersect, that means I have no solution. So parallel lines have no solution because they never intersect. So there's no ordered pair that ever makes both of these true at the same time.